This is the 5th video of the Calculus 3 series on integrating using partial fractions for OCR Pure Core Further Mathematics. And it looks at integrating partial fractions with denominator of form ax plus b cx squared plus d. We know it often helps to rewrite the integral of an algebraic fraction in partial fractions, as the integral can then be split and handled as two or more separate integrals. So in the case of quadratic factors, you may end up with more than two integrals, one of which may be an arctan x type of integral. You will remember that we looked at arctan x being used in integration in previous videos. We have met the algebraic fraction in this integral before, and quick inspection can reassure us that it's a linear factor in a numerator and a cubic expression when it's expanded out in the denominator. As we've previously done the work to expand this algebraic fraction into partial fractions, we will not repeat this here. And so we can now write the integral in the form of 1 over x plus 1 dx plus 2 of x squared plus 3 dx minus x over x squared plus 3 dx. In the grey boxes, the standard results for integration are written, just so you can see where I'm getting my working from. So, integrating that first expression then, I would have log x plus 1. And then the second expression would be minus a half ln x squared plus 3. And then for the third, it would be plus 2 over root 3 arc tan x over root 3 plus c. If you're wondering about the root 3, it's because I'm using the a squared plus x squared here, where I have the x squared, and so I'm saying that a squared equals 3, and therefore a must be root 3. I can tidy that up a little bit in terms of the logs. It would be log of x plus 1 over the square root of x squared plus 3, and then plus that 2 over root 3 arctan x over root 3 plus my constant of integration. Summarising the options then for integrating partial fractions with various forms of denominator. First, we do check that the denominator is a higher power than the numerator. We may need to find an integer and remainder. Any algebraic fractions need to be split into partial fractions. Once you've done this, then the original integral can be split and handled as separate integrals, using the standard results of the forms we have seen. For quadratic factors, you may have more than two integrals, one of which may be an arctan x type of integral, so do look out to use these standard results. If there is more than one log in the answer, they can be combined into a single log. This is the last video in the Calculus 3 series.